Tahniah. Siaran langsung ini dibawakan khas kepada anda oleh Akademi YouTuber Malaysia. Sebuah inisiatif e-didik Malaysia dan Kelab Guru Malaysia. Tumpukan perhatian anda. Siaran langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Hello, Assalamualaikum semua dan salam sejahtera. Okey, hai semua para guru, ibu bapa yang dihormati dan para pelajar yang cikgu kasihi sekalian. Okey, selamat datang ke Pusat Tuisyen Akademi YouTuber AYU, usaha sama e-didik Malaysia dan Kelab Guru Malaysia. Okey, bermula percuma, selamanya percuma. Okey, untuk mendapatkan keberkatan kelas kita pada petang ini, mari kita sama-sama mulakan kelas dengan membaca Ummul Kitab Al-Fatihah. Okey, apa khabar para pelajar? Apa khabar para pelajar yang cikgu kasihi semua? Okey, harap semuanya berada dalam keadaan baik dan bersedia untuk meneruskan kelas kita pada petang ini. Okey, cikgu percaya pelajar-pelajar dah tak sabar nak mengikuti kelas kita kali ini. Okey, cikgu perkenalkan diri. Okey, cikgu Nik Mawar Hanifah binti Nik Hassan. Okey, dari Kuantan Pahang. Okey, selaku moderator kita pada petang ini. Okey, hari ini kita ada kelas tuisyen Prayu, Kimia. Okay. And then pada petang ini, kita bersiaran langsung dari channel Cikgu Shahnon. Okey, sesiapa yang belum subscribe Cikgu Shahnon, silalah tekan butang subscribe, tanda sokongan kepada Cikgu Shahnon. Okey, untuk makluman semua, nama penuh beliau ialah Cikgu Mat Shahnon bin Awi. Okey, selaku ketua panitia kimia bagi tim AYU. Okey, beliau dari Kolej Matrikulasi Pulau Pinang. Okey, tajuk yang akan disampaikan oleh Cikgu Shahnon pada petang ini ialah Hydroxy compound, iaitu Nomenclature and Physical Properties. Okey, khas untuk pelajar kimia SGPM semester 3, atau pelajar matrikulasi semester 2. Okey, pelajar dan para penonton lain dialu-alukan untuk mempelajari topik berkenaan. Okey, kelas ini akan berlangsung lebih kurang 1 jam. Okey, kita ada 1 jam sahaja. Okey, bersama cikgu di studio pada petang ini juga ialah kita ada di bawah sana Teacher Aileen atau Cikgu Liu Aileen, yang mengajar matematik SC dari SMK Datuk Penggawa Timur, sebagai control host. Kita juga ada Cikgu Kong Swet Lee, yang mengajar kimia di Kolej Matrikulasi Perak sebagai pemerhati. Sebelum kita teruskan kelas kita, suka cikgu ingatkan supaya semua pelajar dan penonton yang ingin menghantar komen menggunakan bahasa yang sopan, gambar profil yang bersesuaian untuk tontonan umum. Pada akhir siaran nanti akan ada link sijil e-didik, dan masa hanya diberikan selama 30 minit. Untuk mengisi maklumat dan pastikan menggunakan email e-didik sahaja. Cikgu percaya pada petang ini semua orang dah tak sabar nak belajar. Semuanya pelajar-pelajar yang cemerlang. Mari kita tunjukkan disiplin yang terbaik. Saya teruskan majlis dengan mempersilakan Cikgu Shahnon untuk menyampaikan kelas beliau. Dipersilakan Cikgu Shahnon.
Assalamualaikum warahmatullahi wabarakatuh dan salam sejahtera. Apa khabar semua? Diharapkan semua dalam keadaan sihat, baik semua. Alright, this is my poster as usual. Our class every Saturday 3:30 PM, Kimia Prayu. Alright, and then this is my profile. Wait a minute. Gonna stop Sharing saat dia tak berjalan. Okay. Wait a minute. Share screen. Hide screen. Okay. Alright. Is it okay?
Yeah, it's okay.
Okey, Cikgu Shahnon.
Alright. This is my setting. I don't know why I cannot do the window setting, only entire setting. Okay. This is my profile. My name is Shahnon bin Awi. Institution College Matrikulasi Pulau Pinang. Teaching experience 20 years. And my channel is Shahnon channel. This is our team. Kimia Prayu. We have Teacher Yi, Teacher Lau, Teacher Tang, me, Cikgu Mawar as a moderator, and Teacher Kong as a observer. Okay. And then we have mathematics teammates led by Teacher Im. Here is Teacher Eileen, our moderator today. Teacher Zainaria. Okay, and the rest is still waiting for to present something. I think Teacher Zanaria here. He also Teacher Zanaria present also as a presenter also. And then we have Balaji Prayu, led by Cikgu Faiza, and then we have Cikgu Fatia, Cikgu Naini, HR, and Cikgu Wawa. Per-accountant and economy Prayu, matriculation and also STPM, led by Madam Fizi, Cikgu Yati, Cikgu Lee, and Cikgu Yi. And last but not least, physics. Okay, physics led by Teacher Im. Teacher Im from mathematics, but leads by Teacher Im because they still want to learn something from Teacher Im. Okay, and then this is our portal, Academy YouTuber Malaysia, Pusat Tuisyen AYU, Pusat Tuisyen Percuma pertama di Malaysia. You can surf www.academyyoutuber.com. Okay, more information we can get from here. All right, go to our topic, hydroxy compound. Okay, hydroxy compound. So today only introduction, nomenclature, and physical properties of alcohol. All right, our objective, number one, is give general formula of open change alcohol. Hydroxy compound actually is a functional group, and the compound, usually we call it as alcohol. And then draw, classify, and name the alcohol according to IUPAC nomenclature. Classify the alcohol into methyl, primary, secondary, and tertiary, and then explain the physical properties of alcohol. Okay. What is hydroxy compound? Actually, alkane with hydroxyl group. Hydroxyl group is OH. Okay, OH is a functional group attached to alkane. Not only alkane, maybe alkene. Okay, so we call it hydroxy compound. General formula for open change aliphatic alcohol, CnH2n plus 1 OH. That means one of the H is replaced by OH. And it start from N equal to 1. Okay, N equal to 1, N equal to 2, and so on. And also we have aromatic alcohol, alcohol with benzene ring. Okay, in this case we have hydroxy group and then also benzene ring. And the last one is phenol. Phenol, OH hydroxyl group attached directly to the benzene ring. So this one we call it phenol. So we have three type of alcohol or hydroxy compound. This is the first one, aliphatic alcohol. We call it aliphatic alcohol. OH group attached directly to the alkyl group. Okay, this one OH attached to alkyl group. We call it alkyl group. OH attached to alkyl group. So this is aliphatic alcohol. For aromatic alcohol, we have a benzene ring here, and we have also hydroxyl group, and the OH group attached to R, alkyl. OH attached to alkyl, not direct to the benzene ring. Okay, same things here. So we call it aromatic alcohol. Okay, alcohol with benzene ring. And the third one is phenol. Okay, this one we call it phenol because OH directly attached to benzene ring. Okay, directly attached to benzene ring, or we call it aryl. Okay, so this one we call it phenol. This one is phenol, and phenol. Why this is a different classification? Because of different in chemical properties. All right. Okay. Now we go to the classification. Number one is methyl alcohol, OH attached to methyl. This classification, just like haloalkane, right? In haloalkane also we have methyl haloalkane, primary haloalkane, secondary haloalkane, and tertiary haloalkane. This one also the same thing. OH attached to primary carbon. This one is primary carbon. This carbon attached to one carbon. This one is secondary alcohol because OH attached to secondary carbon. This carbon attached to other two carbon, and so on. And then we have a tertiary alcohol. This classification very important because we will have a different reaction usually in Lucas reagent, okay, and also in elimination. Okay, now we look at the name. This one is IUPAC name, and this one is general name. Okay, CH3OH. This is we have one carbon, so easy for us to name the structure. From methane, it's become methanol. Methane become methanol. And for general name, we take it as alkyl. So this is methyl, and then OH is alcohol. Just like haloalkane. Haloalkane also we have, if OH is replaced by chlorine, for example. So the name for this structure is methyl chloride. Okay, the same thing goes here. Methyl alcohol for general name. This one is ethyl alcohol, general name, and for IUPAC name is ethanol. Okay, come from the root name is ethane. Now it's become ethanol. This one is isopropyl alcohol, and IUPAC name is 2-propanol. Start from 3 carbon, propane, okay, propane, and then we have hydroxyl group. Then we have to name it as 1-propanol and 2-propanol. If hydroxyl group attached to carbon number 1, then we have to name it as 1-propanol. Because in this case, we have to differentiate differentiate it because it has what we call isomer, okay, positional isomer. In this case, we have a primary, no, not primary, positional isomer at carbon number 1 and at carbon number 2. In case of ethyl alcohol or ethanol here, if we change the OH from here to here, it's still the OH still at carbon number 1. So for ethanol, no need to put number 1 ethanol. The same thing goes to methanol. It is wrong if we put 1 methanol or 1 ethanol. But for propanol, it is compulsory for us to put 1 propanol and 2 propanol. Okay, and then we have cyclohexanol. This is without OH. The name is cyclohexane. Now it's become cyclohexanol, or the general name is, this one is cyclohexyl, and this one is alcohol. The same thing goes to the cyclic alcohol. Okay, cyclic alcohol. No need for us to put 1 cyclohexanol. No need, because if we change the OH to this carbon, the name is still cyclohexanol. if we change to this carbon, the name still cyclohexanol. So no need for us to put one cyclohexanol. If we put one cyclohexanol, that's not right. Not right means wrong. Okay. All right. The suffix e in the alkane, okay, we have a parent name is alkane replaced by ol. This is how we get methane, methane. Okay, e we replace e and replace it all. So now it's become methanol. The location of the OH on the longest change is given by the smallest possible number. This is if we have a very long parent change, and then make sure that OH get the smallest possible number. Okay, now we go to the IUPAC rule for naming alcohol. Okay, here is number one is we have to determine the parent's name. Okay, how many carbon? If 5, make it pen. We know the name is pentanol, something like that. And then give the lowest number to the carbon bearing the OH group. The OH group should get the smallest possible number. Okay, maybe number 1, maybe number 2, number 3, and so on. And then we can identify the substituent group and their position. Okay, name the alcohol. If we have an alkane with one OH group, the name is alkanol. Methane become methanol. Okay, ethane become ethanol, propanol, and so on. If OH group attached to alkene, sometimes we have a compound that have carbon-carbon double bond. Now the name is become alkinol. Okay, we just change the A here to E, alkinol. All right, for one OH. This one not means the OH at carbon number 1. This one means we have only one OH group. Okay. If we have two OH group, so now we take alkane. The name should be alkane, and we add diol. So the name becomes alkane diol. For example, we have butane, and then we have OH. Okay, two OH group. So now the name should be butane diol. Okay. Alkene, we have OH group. We change here, alkene diol, alkene. And if we have a 3 OH group, so now the name is alkene triol, something like that. If 4 alkene, number 1 is di, tri, and then tetra. 4 is tetra. Okay, this is how we name alcohol according to their how many OH group. Okay, now we look at for phenol. For phenol, carbon attached to OH group always is carbon number 1. Okay, this is phenol. Okay, OH. If we want to name this compound, this is phenol, and OH carbon that bearing OH group gets the smallest number. This is number 1, so that the ethyl here carbon number 3. 1, 2, 3. 3 ethyl phenol. Or because this is two substituted benzene, we can name it as meta. Okay, meta ethyl phenol. Also, we can name it as meta. Let me write the name. Okay, this one. Also, we can ethyl phenol. Okay, because this is two substituted benzene. Okay, we call it two substituted benzene. Only two. We can use auto-meta-para. This one also, okay, this is number 1, number 2, number 3. So 3 bromophenol, or also meta here. Meta M. Meta is meta bromophenol. For this one is auto, right? This one is auto methyl phenol. Okay. OH, carbon that bearing OH must get carbon number 1. Okay. This is what I mentioned before. We have two OH 2 OH here, 2 OH, here, 2 OH, add carbon number 2 and number 1 and number 2. So the name is 1, 2, ethane. Okay, we take the real name of ethane. Okay, 2 carbon is the parent's name is main ethane. So we just take ethane and then we just add diol, add carbon number 1 and number 2. And this is general name, ethylene glycol. Okay, ethylene glycol. This is general name for IUPAC. Okay, not easy to remember the general name, right? The IUPAC, yes, because it is always very systematic. It's easy for us to write the name in IUPAC. Okay, here we have 1, 2, 3 carbon and OH at carbon 1 and 2. So the name is 1, 2 propane. Okay, we take the propane and then diol. And this is general name propylene glycol. And here also we have 1, 2, 3, 1, 2, 3 at carbon number 1 and number 3. Easy for us to write the name in IUPAC. Okay, 1, 3 propane diol. But for general name, trimethylene glycol. We cannot see the connection, right? No connection. Because for general name, yes, we have to remember. Not easy. Okay, for this one, 1, 2, 3. In this one, we have 3 carbon. So propane, propane, and because of 3, triol, triol. Okay, 1, 2, and 3, propane triol. General name is glycerol, glycerol. Okay, the most important thing is if you have this kind of structure, just use the IUPAC name. Easy for us to write them. Okay, for benzene, benzene derivative with 2 OH group, our name is benzene diol. Yes. So if we have we cannot name it as this one is as a phenol, and then 4 hydroxyphenol. Okay, no. We will name it as we take benzene as a parent. When benzene as a parent, so just take it benzene because we have a 2 OH group, similar like with this one. We have 2, right? We just take the real name of ethane. Okay, the parent name is ethane. So we just take it ethane. For the same thing goes here. We have a 2 OH group, so we take the real name of the parent's name for this one, which is benzene, and then diol because we have 2 OH. So this one is one for benzene diol, and this is general name for this compound, hydroquinone. This hydroquinone very popular in 1990, I think, 1990 something, very popular. Okay, hydroquinone used in cosmetic to get flawless, flawless, flawless skin in our face. And we have also 1,3 benzene diol because 1 and 3, right? So we just take benzene and diol or isocyanates and 1,2 benzene diol catechol. Catechol. This one not easy for us to remember, but this one for the IUPAC name, yes, I think not the problem. Okay. Okay, now we have a practice question. Okay, how many times that I have right now? Okay, moderator, how many times now?
Okay, now 3:54.
6
We
minutes.
have
6
6,
minutes.
6
Okay, 6
minutes
minutes.
left
Okay.
before rest.
Okay, 6 minutes. So we try to name this compound. Name the following compound using IUPAC nomenclature. Okay, student, try to answer this question. This one is very easy. This is aromatic. Okay, this is aromatic alcohol because we have OH and also we have a benzene ring. Okay, can anyone answer this question? Just write in the check box. This one is very easy. I can put it the number here. Okay, the OH should get the lowest possible number. That's mean number 1. This is number 2. This is number 3. Okay. This is substituent. In bracket is substituent. Also, the benzene also becomes substituent. Okay, student. Anyone? Anyone want to answer this question? Very easy.
So students, write your answer in the chat box. Wrong, so
Yeah.
doesn't matter. Please try only.
Try. Okay. For this benzene, when it's become substituent, the name is phenyl. So many. Oops. Phenyl. So many tips. This is phenyl. This is methyl. Okay. Name this aromatic alcohol. When write the name, it must be alphabetical order. Okay, A B C D E F G H I J K L M N O P. So M first, and then P. Okay, anyone? Anyone? Very easy. Noah.
So far they have no answer yet, Cikgu Shahnon.
I think they are shy.
Okay.
Too shy to write.
Shy.
The name is 2-methyl 3-phenyl 1-propanol. Okay, 2-methyl 3-phenyl A B C D F G H I J K L M N O P. Okay, P. And then 1. Don't forget to add 1 here because this is 3 carbon. 1, 2, 3. 3. 3. 3 propanol. Okay. The second one. Okay, anybody? Okay, I just show you many question here, so you can choose whether B or C, or D or E. No F. A B C D should be F. The E should be F. Okay, student, you can choose anyone that you think easy to answer.
Yeah, students, please try. You need to try when you are in the learning process.
Yeah.
Don't be worried about wrong or correct. Just try only.
Okay, I give the this one
I think Cikgu Shahnon kena bagi clue ni. Bagi clue sikit
itulah
nama
nak bagi clue lah.
substituent tu.
Okay,
Substituent dia.
this one nitro. Okay, this is nitro, the substituent. This one is cyclohexane lah kan? Cyclohexane all. Betul ada nitro. Add carbon number. This one you have to use the parent name as a phenol. Okay, use phenol. PHENOL. And this one is bromo. Okay, this is a clue. Okay, you can write. Okay, this one we have a double bond and then OH. You have to use alkenol, as I said. This one, the alkenol. Okay, alkenol. OH should be number 1. This one number 2, number 3, number 4, number 5. Here we have a methyl. Here 3 carbon. 1, 2, 3. Isopropyl. So when you name it, okay, look at this one. This one is cyclopen. The root of the name is cyclopentene. Now it's become cyclopentenol. Okay, cyclopentenol. OH, no need for us to write the number. We have to write the number of double bond. Okay, double bond in this cycle. That's mean so the parent should be 2 cyclo Mid it pentinol. Okay, pentinol. Okay, the rest you have to write the uh, substituent according to alphabetical order. A B C D F G H I J K L M. Jadi boleh write. This one, okay, this one we have a double bond and then we have two OH. Alright. So 1, 2, 3, 4, 5. The root name is 5. Mid it pen. Pentene. Pentene diol. Yeah, where is it? Okay, pentene. So double bond pentene. Tin. Okay, pentene. Add carbon number 2.
Okay, they have one answer here from
Okay.
Daniel,
Okay.
revolution. B question, 2
Okay.
nitrocyclohexanol.
Yes, correct. 2
Alright.
nitrocyclohexanol. Good. Okay.
Okay, Cikgu Shahnon, sementara we wait
Hmm.
for the other answer, I think that we have
Okay.
to take a break for a while.
Okay.
Okay.
1, 2, 3, 4, 5. Okay, iklan.
Cikgu Aileen.
Teacher Aileen, iklan.
Tahukah anda tuisyen online percuma? Ya, pertama di Malaysia. Gandingan para guru menghasilkan yang terbaik, memenuhi keperluan pembelajaran anda. Semua mata pelajar percuma. Dibawakan kepada anda oleh Akademi YouTuber Malaysia, Inisiatif Didik Malaysia dan Kelab Guru Malaysia. Tahniah, terima kasih.
Okay, we're back. Okay, Cikgu
Okay, welcome
Shahnon.
back. Yeah.
Okay, go ahead.
Okay, what about C? Anyone? C, the
Okay,
parent
for
name is
C,
phenol.
Sarah Shamimi have answered 2 bromophenol.
2 bromophenol, right? Good. 2 bromophenol. Okay, D. D is quite interesting, but I already give the clue here. The carbon at number 2. Now the parent's name is 2-cyclopentenol. Remember that the penti here adalah pentenol. Okay, because only one double bond. If you have 2 double bond, look at here. Pentene, P-N-T-E-N-E. Oh, what happened? Okay. Okay, this one.
Okay, before
Okay.
that, Aidatul Adawi pun also answer C as a 2 bromophenol. Cuma is nampak dekat tu
Okay.
dia letak one gap. Dia letak gap dekat between bromo and phenol. She put gap there.
No, gap. Okay, no gap.
Suppose kena rapat lah.
Ya. In IUPAC name, huruf dengan huruf, huruf dengan huruf kena rapat. Except for
Okay, the answer. Okay, we have the answer for D, Daniel Revolution. 5 isopropyl, 3 methyl, 2 cyclopentane, 1 ol.
Okay, no need to add one. Okay, for cyclic alcohol, if we have only one OH, so no need one OH. So just remove one. So cyclopentenol. Okay. 5 isopropyl, yes, because I and then M. Jadi 5 isopropyl, 3 methyl, and then 2 cyclopentanol. Okay, just write that 2 pentanol. For cyclic alcohol, if we only have one OH, no need for us to, and OH is the parent's name because this is alcohol. If we have something that superior than OH, for example, carboxylic acid, for example, then OH we have to write the number. Okay, but this one OH is the superior from carbon-carbon double bond. So we assume that uh, uh, the carbon at OH is always number one. Okay. Okay. What about E? Actually, this is F. D, A, B, C, D, E. Oh, okay. No. Oh, betul ya. E. Okay. This is I think I have to give the name for this one. First, we want to know the OH, the number for OH, the smallest number. It is clear that OH at carbon number 1 and number 5. And then the smallest number for double bond is number 2. We cannot count from here to here because we will get the double bond at carbon number 1, 2, 3. So should be from right to left. And then the parents is 2 pentene. Look at pentene here. E and E because we have 2 OH. So we have to take pentene. We cannot remove E. Okay? But this one we remove E and then we here PETE and E, no E here, we remove and we change with OL. Okay, so it's become pentanol. But this one pentene and then diol. Okay, number 1 and number 5. So we know here that number 1 at carbon number 2. Okay, number 1 at carbon number 2, and at carbon number 1 and 5 we have OH group. And then look at here, we have at carbon number 4, we have methyl. So 4 methyl and then dash. Okay, between number and words, huruf kena ada hyphen this. Okay, clear for this. And then we go to the second part, physical properties. In physical properties of hydroxy compound, we have two. Number 1 is boiling point. Number 2 is solubility in water. Okay. Most simple alcohol are liquid. Methanol, METOH is methanol. Okay. Ethanol, ETOH is ethanol. This is just to make it simple. Methanol and ethanol are volatile liquid. Okay, respectively at 65 degrees Celsius and 78 degrees Celsius, it's boiling point. When the molecular weight of methanol alcohol increase, then the boiling point also increase. Alcohol with carbon more than 12 are solid, usually solid. And if we have a increase in number of OH group, then the boiling point also increase because stronger hydrogen bond. We know that between molecule of alcohol, they can form hydrogen bond. Okay, and if they have more OH group, that means they can form more hydrogen bond. That's why stronger hydrogen bond and stronger and higher boiling point. If we try to compare the boiling point of alcohol, alkane, and haloalkane, of course, alcohol has a higher boiling point because of hydrogen bonding. Okay, alkane is only weak van der Waals. X haloalkane is only also van der Waals, but they are polar. Okay, and boiling point of a straight change alcohol usually higher than branch alcohol, and boiling point of primary alcohol greater than secondary alcohol and tertiary alcohol for the same molecular weight. Okay, same molecule. So from here, I just give a tips how to predict the boiling point of some of the alcohol, first we have to look at the number of each group. If the compound has greater number the greater number of each group, so we can consider it has a higher boiling point. And then the second one is we look at the molecular weight. Okay, because molecular weight refer to the molecular size. Okay, refer to the molecular size. That means the size of compound very big if we have a higher molecular weight. And then look at the linear or branch. Usually linear, the linear should get higher boiling point. And then we look at the class of alcohol at for the same molecular weight, whether it is primary, secondary, or tertiary. The primary should get the boiling point of a higher boiling point. Okay, practice question. I know that not many of you like to answer this question. Arrange the following compound in order of increasing boiling point. Okay, okay. We just look at this. I just want to give the tips. Here we have two OH group. Okay, this is one. This is one OH group. OH ah. Oh, gila. This one also one OH group, and this one also two OH group. Use the tip that I where is the tip? Okay, this is the tips. Okay, first you have to look at the number of OH group. Okay, arrange the following compound in order of increasing. Okay, you have to choose the lower boiling point first. So you have to look from here. It should be one OH group. Okay, one OH group. Either this one, 2 or 3. 2 or 3 should get the lowest boiling point. Okay, this is the, so look at this one first. Okay, that is number of OH group. And then if you look at this one, this is what we call it, isomer. Isomer, right? This is primary alcohol. This is secondary alcohol. So which one? Which one should get the lowest boiling point? Any answer from the floor?
So far, not yet.
No, yeah, A, B, C, or D. Yeah.
Okay, student, you can answer, student. Just put A, B, C, or D.
Okay, we have 2, we have 3, we have 2. This is clear that C, we can replace C lah. Because 1, if you look at 1, it has 2 OH group. So this one is 1 OH group kan. So the 2 OH group, the boiling point of higher number of OH group should be greater in boiling point compared to 1 OH. Okay, we can remove C. Remove C. Now you have A. Should be A. If you know, the point should be here. The point should be here, number 4. Point should be number 4, class of OH. Class of OH. Same molecular weight. Same molecular weight. So which one? If you know this one, you can answer this question easily. And okay, we look at this the highest boiling point. The highest boiling point should be number of H group must be higher and higher molecular weight. So which one? Number 1, we have 2 H group. Okay, number 4 also we have 2 H group. Which one is higher molecular weight?
Okay,
So,
we have one answer here.
Okay, answer. Okay, good.
Okay, Sarah Shamimi answered D, donkey.
D, donkey. Okay, one answer. Okay. If you look at this one, yes, should be 4. 4. This one we can remove. Because the 4 is higher number of H group and higher molecular weight compared to 1. So the answer should be 4. But the problem is 3 and 2. Okay, 3 and 2. Look at 3 and 2. Or 2 and 3 lah. 2 and 3. 2 and 3, class of alcohol is same. Which one is has higher boiling point? Primary or secondary alcohol? Primary or secondary? Okay, we look at this one. Boiling point, primary alcohol greater than secondary. Same molecular weight. Okay, so the answer should be B. B lah. B because actually when we write the secondary alcohol like this, okay, compared to primary, this is primary. It looks like the secondary one like has a branch, right? Linear or branch. The secondary one, look at the secondary. It looks like has a branch over, and for a branch organic compound, we know that when it's branch, it's more spherical, and the contact surface area becomes smaller. That's why the boiling point becomes less compared to the primary. Primary looks like more cylindrical. Okay, higher contact surface area. Okay.
Munirah Osman got the correct answer, B.
Correct answer B. Okay, good. Okay. Now we go to the solubility. Okay, solubility. Solubility, alcohol and water have the ability to form intermolecular hydrogen bonding. Methanol, ethanol, and pro-O to propanol lah. Pro-O are completely soluble in water. Okay. And solubility decreases with relative molecular weight because the bigger hydrophobic area. When we talk about solubility, we have to add this what we call this term, hydrophobic and hydrophilic area. Okay. Solubility increases with the number of each group. Okay. When we have number of a group means hydrophilic area. I mean, this one, hydrophilic area. Okay, hydrophilic area can form hydrogen bond with water, means hydrophilic area can soluble in water. Hydrophobic area, when the molecular weight become bigger, then the solubility will decrease. This is we can see the differences with boiling point. In boiling point, the higher the molecular weight, the higher the boiling point. But in solubility, the higher the molecular weight, the lower the solubility. Okay, don't get confused about the molecular weight. Actually, the molecular weight we refer to the molecular size. Okay, this is hydrogen bonding between alcohol. This is alcohol, R, OH, and O. We know that partially negative, and this is hydrogen from water. So in solubility, hydrogen bonding between alcohol and water. Without water, hydrogen bonding between alcohol and alcohol. Remember this. Sometimes when student write the answer, they talk about solubility, but the hydrogen bond is between alcohol and alcohol. That's wrong, right? So remember, in solubility, intermolecular forces of hydrogen bonding between alcohol and water. That's why it's soluble. That's why alcohol soluble in water. If you talk about intermolecular forces between alcohol and alcohol, that means you're talking about boiling point. Okay, boiling point, not solubility. Okay, this is hydrophilic area, OH, as I mentioned before, and this is hydrophobic area, the R, the alkyl group. We know that alkyl group cannot form hydrogen bond with water. That's why it's become hydrophobic area. And OH can form hydrogen bond with water. That's why we call it hydrophilic area. Okay. If the R is very big, so it's not easy for that molecule to soluble in water. That's why methanol, ethanol, and propanol miscible in water completely 100%. Okay. Now we go to the phenol. Phenol is not completely soluble in water. All right, below 66 degrees Celsius. Okay, above this temperature, it will completely soluble. And then phenol is colorless, crystalline solid, which is hygroscopic. Hygroscopics mean the phenol absorb moisture. Okay, if we have a crystalline solid, that's mean dry solid of phenol, and we place it in place it in, for example, in beaker, and after some time we will get it like wet, okay, because it absorb moisture from surrounding. Okay, and if we have 4-nitrophenol and 2-nitrophenol, same molecular weight, okay, but different in position of nitro, we can see that 4-nitrophenol is more soluble. Okay. This is because, this is 4-nitrophenol because we know that oxygen here from nitro also can form hydrogen bond, and hydrogen here from phenol also can form hydrogen bond with water. But for 2-nitrophenol, because the position of OH and nitro quite near, so they can form hydrogen bond between them. We call it intramolecular hydrogen bond. So not easy for nitrophenol to form hydrogen bond with water, something like that. And this one, for nitrophenol can form hydrogen bond with water here also. So for nitrophenol more soluble compared to 2-nitrophenol. Okay. Okay, now we have a practice question. How many minute that I have? Okay, 8 minute. Okay, this is the tips. Before we have the question, we have a tips. Compound, polar, or non-polar. Okay, we look at this one. And then number of each group. Okay, hydrophilic area, as I mentioned before. Okay, the larger number of each group are more soluble in water. And molecular weight. Molecular weight is hydrophobic area. The larger the molecular weight, less soluble in water. Okay, and then linear and branch. Okay, if we have a linear, that's mean not easy to soluble. Okay, because linear for branch is become more spherical and easy to soluble compared to linear. Okay, the question is, arrange the following compound: 1,2-propanediol, pentanol, and butane, 1-propanol, 2,2-dimethyl propanol, in the order of increasing solubility in water, and then explain. Okay, use this tip. Compound, polar or non-polar. If you look at here, we have a diol, all. One is not all, and butane. And butane is alkane. We know that alkane is not soluble in water, so this and butane should be here, and then followed by, we look at this number of OH group, less OH group, and higher molecular weight. Okay, I give the answer. This is the answer. And butane, and then pentanol, and then 2,2-dimethyl propanol, and then 1-propanol. The last one is 1,2-propanediol, because this one has 2 OH group. So this is more polar, more OH group, can form more hydrogen bond. So this one soluble in water. Okay, soluble in water. Compared this one have 1 OH, and 1 OH. Okay. Okay, solubility in water increase. Okay. Okay, any okay. Actually answer. Okay, I answer lah this question. Okay, and butane is a non-polar molecule. Okay, cannot form hydrogen bond with water. Hence, and butane insoluble in water. Okay, we know that this is alkane. Alkane is non-polar, so insoluble in water. Now we look at this one. This one, we have to clarify why this is 1, 2, 3, 4 here, soluble in water. So pentanol, 2,2-dimethyl propanol, 1 propanol, and 1,2-propanediol can form hydrogen bond with water, so that they dissolve or soluble in water, soluble in water. Okay, okay, that is point number 2. Point number 3, we have to differentiate with 1 OH and 2 OH. All right, this one we differentiate between non-polar and polar, cannot form hydrogen bond and can form hydrogen bond. The third point is we differentiate 1 OH, oh no, this one, we take this 3 here, this 3 here. 1 OH, 1 OH, both pentanol and 2,2-dimethyl propanol are isomeric. This one, pentanol has 5 carbon. Propanol, 2,2-dimethyl propanol, also 5 carbon, and they are isomeric. Pentanol is straight change alcohol. Hydrophobic area is larger. Okay, this one, linear or branch. For straight chain hydrophobic area larger, and then less soluble in water compared to 2,2-dimethyl propanol. More branch, and then hydrophobic area is lower. So more soluble than pentanol. Okay, so this point, we take this point. Point number 4 is between here and here, because this has 3 carbon, this is 5 carbon, this one molecular weight, hydrophobic area. Okay. 1 propanol has lower molecular size. Okay, lower molecular size. Molecular weight means for lower molecular weight means lower molecular size, smaller hydrophobic area, and more soluble in water compared to 2,2-dimethyl propanol and also pentanol. This is point number 3. And point number 4. Point number 4. Yeah, point number 3 from here. Okay. And the last one is 1,2-propanediol has 2 OH group. 2 OH group. Point number 2 here. More hydrophilic area. We have to use hydrophilic area. Can form more hydrogen bond with water. Therefore, more soluble. Alright, this is how we answer this question. We have to look in detail what this compound has, whether polar or non-polar, number of H group, which mean hydrophilic area, molecular weight, hydrophobic area, or molecular size, and then linear or branch. Okay. Don't get confused with boiling point. As I said before, in case of a boiling point, remember this one, molecular weight. Molecular weight. This one quite confusing. Okay, this is the last one. How many times did I? Oh, right. Arrange
Cik
the
Shahnon,
following
we
compound.
have 2 minutes, 2
Yeah,
minutes
I
left.
know. So many. Okay, this is the last one. Arrange the following compound in order of increase boiling point and solubility. Because I give this question, I want to show how we answer this question, how we arrange this according to the point that I has given before. Okay, if you look at the boiling point, okay, we want to arrange in order of increase in boiling point. Okay, the first one is of course N-butane. N-butane is non-polar, and then the intermolecular force is weak van der Waals forces, and so on. Propanol, ethanol, ethane diol, and 1-propanediol. This is the intermolecular forces is hydrogen bond. So hydrogen bond is stronger than van der Waals forces, right? So, and then look at here. This is 1-propanol. this is 1 OH and this is 2 OH. Okay, diol, this 2 OH. And this one, we have a propane diol, greater molecular weight compared to ethane diol. So the boiling point should be like this. For solubility, all right, and butane, insoluble, we know. And this one is because 1 OH and this one is 2 OH group. But in this case, remember the molecular weight. The higher the molecular weight, the lower the solubility in water. So we change this one, 1,3 propane diol. And the solubility of 1,2 ethane diol is the highest compared to one. So don't get confused with how we want to arrange the boiling point of alcohol, right? Okay, this is the tip. Okay, this is the tips. Number of H group, molecular weight. This is class of alcohol, same molecular weight as I mentioned before. And this is tip for solubility, polar or non-polar, number of H group, hydrophilic or hydrophobic area, linear or branch. Okay. So I think that's all for today. Thank you very much. Please subscribe, like and share. And this is my YouTube channel, www.youtube.com/Shahnon channel. Okay, go back to our moderator.
Okey, terima kasih diucapkan kepada Cikgu Shahnon atas perkongsian ilmu yang sangat bermanfaat dan mudah difahami harapnya ya. Okey, terima kasih juga kepada Teacher Aileen membantu kita, Madam Kong. Alhamdulillah selesai kelas kita pada petang ini. Tahniah diucapkan kepada semua yang setia mengikuti kelas kita daripada awal sampai ke saat ini. Okey, sebelum kita tamatkan sesi siaran langsung, mohon tutup ruangan chat, klik butang subscribe, aktifkan ikon loceng supaya para pelajar tidak terlepas sesi kelas yang seterusnya. Sekiranya anda suka dengan apa yang dipelajari, sila klik like, share kepada kawan-kawan di media sosial anda untuk sebarkan ilmu dan beroleh kebaikan melalui perkongsian tersebut. Seterusnya link CJ dah ada di sana. Nanti anda boleh dapatkan di bahagian chat. Sila ambil perhatian. Link akan tamat dalam tempoh setengah jam selepas live ini. Pastikan anda guna email e-didik sahaja. Sekali lagi Cikgu ucapkan ribuan terima kasih kepada Cikgu Shahnon atas kelas pada petang ini. Jangan lupa untuk dapatkan jadual tuition online terkini melalui portal www.academyyoutuber.com serta dapatkan info terkini. Bantu cikgu untuk sebarkan kelas tuition percuma ini kepada rakan-rakan dan guru-guru seluruh Malaysia. Semoga kita mendapat manfaat daripada kelas-kelas yang dijalankan. Ingat hashtag bermula percuma selamanya percuma insya-Allah. Terima kasih kepada semua. Segala yang baik datangnya daripada Allah. Jika terdapat sebarang kekurangan dan kelemahan adalah daripada kami. Kelas tuition percuma online. Kelas tuition online percuma berakhir sudah. Di lain siaran berjumpa lagi. Bye semua.
Tuition online percuma. Tuition online percuma. Layari www.academyyoutuber bagi mengikuti tuition online secara percuma. Prasekolah, sekolah rendah, sekolah menengah, semua ada di Akademi YouTuber. Rujuk jadual di laman sesawang www.academyyoutuber.com. Semoga masa terluang anak-anak anda diisi dengan sebaiknya. Tuition online percuma mestilah Akademi YouTuber.
Dibawakan kepada anda oleh Akademi YouTuber.